So suppose we have a repeated eigenvalues and that satisfy the system x prime equal to a times x. Then there is only one eigenvector v, and x equal to v times e to the lambda t is a solution of the system. Furthermore, another eigenvector can be determined by solving the equations of the form a minus lambda I times u equal to v. Now you have the second eigenvector u, right? And the second eigenvector u can be found depending on the eigenvector v, which can be determined from the repeated eigenvalue. Then I'm going to say this is x2, the solution is equal to u times t e to the lambda t plus v times e to the lambda t also satisfy the system. Okay, so with this idea, we're going to solve the following system. Okay, so you have the system of this form. I forgot one thing here. This is multiplied with x, right? So x prime equal to 7, 1, negative 4, 3 times x. Right there. Okay, and when you actually get the general solution, you can be able to determine the particular solution as well
based on the initial conditions right here.
So first, we need to solve for the eigenvalue. The characteristic equation is that of the determinant of a minus lambda I equal to 0, or you have that is 7 minus lambda 1, negative 4, 3 minus lambda equal to 0. And from this 2 by 2 determinant, you get 7 minus lambda times 3 minus lambda plus 4 equal to 0. Or you get 21 minus 7 lambda minus 3 lambda plus lambda square plus 4 equal to 0. Or lambda square minus 10 lambda plus 25 equal to 0. You can use quadratic formula to solve these quadratic equations, or you can factor it, and the factor is just lambda minus 5 times lambda minus 5. In other words, you're going to have lambda minus 5 square equal to 0. So from here, the solution is just lambda equal to 5. So the eigenvalue is lambda equal to 5. And so you can say this is the repeated eigenvalue. So this is the eigenvalue with the multiplicity of 2. Right? Multiplicity of 2 depends on the power right here. If this is cube, then this is the multiplicity of power 3, right? Or multiplicity of 3. Okay. Now with the eigenvalue, we're going to solve the eigenvector. Next, we need to determine the eigenvector, the corresponding eigenvector. By solving the equations a minus lambda I times v equal to 0. For this first eigenvector, this is the equation that we need to solve. Now later for the second eigenvector, we're going to utilize this equations a minus lambda I times u equal to v. But for now, I'm going to solve this simple matrix vector equation. So you substitute lambda equal to 5 into this part, right? This part is a minus lambda I. So you have this 7 minus 5, this is 1, this is negative 4, this is 3 minus 5, times v1, v2 equal to 0, 0. Okay. So from here, you get this system of linear equations. Right? Let me be careful, let me slow down a little bit. So this is 2, 1, negative 4, negative 2. You get v1, v2 equal to 0, 0. So from here, you got 2v1 plus v2 equal to 0, and negative 4v1 minus 2v2 equal to 0. Again, these two equations are identical, so you just need to choose one to work with. Right? So it's obviously the first one is a little nicer to work with. So from here, you got 2v1 plus v2 equal to 0, or v1 is equal to negative 1/2 v2. So here we choose v2 to be equal to -2, then v1 is equal to +1. Thus, the eigenvector is v equal to 1, -2. Now, for the second eigenvector, right, with the same eigenvalue, we need to move on to find the second eigenvector. Right? To find the second eigenvector, we solve the following equations. Right? So let me be careful here. The equation is a minus lambda I times u equal to v. Right? So this part you know, a minus lambda I, you know, v vector v, you know, which is 1, -2. What you're looking for is the eigenvector u. Okay, or this is 2, 1, -4, -2 times u1, u2 equal to 1, -2. Now again, from here, you can rewrite this as the system of linear equations as 2u1 plus u2 equal to 1, or -4u1 minus 2u2 equal to -2. Again, these two equations are identical. Again, if you notice, if you divide both sides for -2 for the second equation, you get back the first equation. So again, the two equations in the system are identical. So you can do 2u1 equal to 1 minus u2. Or in this case, let's go crazy a little bit. Instead of solving for u1, I'm going to solve for u2. I will explain in a minute why that is the case. So u2 is equal to 1 minus 2u1. Now, as I said earlier, the value, you solve one variable in terms of another variable, right? And one of the variables become a free variable. Therefore, you can choose anything you like, just like in this case, right? In this case, so b2 in this case is a free variable. You can choose anything you like, as long as you don't obtain a trivial solutions or a zero vector. Right? That means if you have this equation and you choose v2 to be 0, then v1 is 0 as well. So that's a trivial solution or a zero vector. However, in this case, right, you can actually choose u1 to be equal to 0 because u2 is going to be equal to 1. So that is not a trivial solution. Right? That is not a zero vector. So that's okay for us. Right? So as you can see, the flexibility when you solve for one variable in terms of another variable, you can either use this equation, it doesn't matter. Right? So in this case, u2 is a free variable. But I noticed that when I let u1 equal to 0, then u2 becomes 1, which is a lot nicer to look at. Right? So that's the reason that I solve u2 in terms of u1. And in this case, u1 is a free variable. So here, we choose u1 to be equal to 0, then u2 is equal to 1. So the eigenvector is u equal to 0, 1. Thus, the general solutions of the system is x equal to c1 times, right, so the first eigenvector is 1, -2, times e to the 5t plus c2 times the second solutions. Now, the second solution, if you go back to the note earlier, this is the second solution. This is the combination, not linear combination, but the combination between u and v. So u is 0, 1 times t times e to the 5t plus 1, -2 times e to the 5t. And that is the general solution. Now, with the general solutions, most of the time we don't know, but here in this case, they give us the initial condition as well. So the initial conditions, so given x of 0 equal to
-5,
we can determine the value of c1 and c2. Right? So that is, remember, in this case, t is equal to 0. Right? So you have c1 times 1, -2 times e to the 0 plus c2 0, 1 times 0 times e to the 0 plus 1, -2 times e to the 0 equal to 2, -5. Now this term becomes 0. And you're left with c1 times 1, -2 plus c2 times 1, -2 times e to the 0 equal to me be careful here. Sorry about this. Can you fix a few things for me, please? This should be V. This should be U. And therefore, when you go down here, the solution should look like this. So the solution is 1, -2. This is 0, 1. This is 1, -2. This is 0, 1. Okay. Therefore, this term is 0. And we get, so C2 times 0, 1 times e to the 0, which is 1, equal to 2, -5. Right, can you please fix that for me? Thank you. Okay. Now from here, you can rewrite this as a system of linear equations in terms of C1 and C2, so that you can solve the C1 and C2. So C1 plus 0 C2 equal to 2, and -2 C1 plus C2 equal to -5. From here, you get right. So from here, you get that C1 is equal to +2, and C2, if we do the calculations correctly, is going to be equal to -1. So the particular solution of the system is, so x equal to, so C1 is equal to 2. So 2 times 1, -2 times e to the 5t. C2 is equal to -1. Right? So that is 1, -2 times t e to the 5t plus 0, 1 times e to the 5t. So let's manipulate these solutions a little bit. So here you got 2, -4 e to the 5t minus 1, -2 t e to the 5t minus 0, 1 e to the 5t. And then you can combine these two terms together. Right? And you get, so 2 minus 0 is 2, -4 minus 1 is -5 times e to the 5t minus 1, -2t e to the 5t. And that is the solution.